In this video, let's just apply what we've learned so far with a few examples. So suppose we want to determine whether 7 is a prime using Fermat's little theorem as the test. So we of course know that 7 is a prime, but let's pretend we don't know that and go through the steps. So 1 to the 7, is that congruent to 1 mod 7? And of course 1 to the 7 is 1, so yeah, 1 is congruent to 1 mod 7. So that is a yes. And let me just say, by the way, that will always be true. So that was kind of pointless to do that, and I just wanted to make that clear. Using a base of 1, that will always work no matter what the number is. Okay, but then it gets a little bit more interesting. Let's do 2 to the 7. Is that congruent to 2 mod 7? So this is the question. Is this true? 2 to the 7 mod 7, is that the same as 2? So what I'm going to do is switch over to Wolfram Alpha and see what 2 to the 7 mod 7 is. And it is 2. Okay, so that's a yes. 3 to the 7, is that congruent to 3? Mod 7. Yes, it is. Letting Wolfram Alpha do all our heavy lifting here. 4 to the 7, is that congruent to 4? Yes. 5 to the 7, is that congruent to 5? Yes. 6 to the 7, mod 7, is that congruent to 6? Yes. Now, 7 to the 7, is that congruent to 7? And I'm getting a 0 here, but of course 7 is also 0 mod 7, right? 7 goes into 7 one time with a remainder of 0. So both of these, apparently, when you mod them by 7, it's 0. So this is a yes. But if you think about it, any number, no matter to what power, if you mod it by that number, you'll get 0 here, and then you'll get 0 here. So again, this is kind of a pointless test. That one's always going to give you 0 and 0. So you actually don't have to do the number itself. That would always work anyway. It's kind of pointless. And then, going forward, 8 to the 7th congruent to 8. Well, that's going to be yes also, but what I want to say here is that since 8 is just 1 mod 7, right, the remainder is 1, this is really 1 to the 7, and this is really 1, so we're just repeating this first test. So it will be a yes, as this one was, but it's kind of pointless. And 9 to the 7, whether or not that's congruent to 9, well again, 9 is the same as 2 when you're in a mod 7 world, right? So this is really the same as asking, is 2 to the 7 congruent to 2, which was this test. So we start to see, oh, this is just getting redundant. 10, when you do 10, it's the same as 3, and so on. Okay, so it's pointless to go on forever. You actually can stop right at the one before your number. So basically, you only have to go from 2 to n minus 1. And if those all check out, you can be sure that all the others will check out. 1, because it always does, and then everything beyond, just because those are just repeats of the ones you've already done. So there is a finite number of Fermat's little theorem checks that have to be done. So 7 passed all of them. All right, so what do we know? Well, we know that 7 is a prime, or it could be a composite Carmichael number. Right? So that's what this approach tells us. If you pass everything, you could be a prime, and actually you probably are a prime, but you might also be a Carmichael composite number. We can't rule that out, right? There are, in rare instances, numbers that are composite, but that pass all of the Fermat's little theorem tests. Okay, now we know 7 actually is a prime, but this test didn't 100% nail it down for us. It just narrowed it down to these two possibilities. Okay. is 27 a prime? Now, we know the answer is no, but let's go through. So I've skipped 1 because we've realized that that was always going to work anyway. Let's jump right into 2, and we'll go from 2 to 26, right? That's what we've decided is that's the range that we have to check, and we don't have to go beyond 26. So is 2 to the 27 congruent to 2? So 2 to the 27 mod 27, and we get 26, which is not 2. So that's a no. So we don't have to go any further. And actually, I didn't have any more underneath this. I knew it would fail on the first one. So what does that tell us about 27? It means 27 is definitely composite. So as soon as you fail one of these, you're definitely composite. You have to be, because all prime numbers have to pass all these Fermat Little theorem tests. Okay. So you've seen one case where it passed, and we went all the way to the end, to n-1, and it passed them all, 7. And we were able to say that it was prime or a Carmichael composite number. And here was one that was composite, and it's because it failed one of the tests, and we were lucky it failed the very first one, so we didn't have to go any further. So we're going to call this the Carmichael test. The Carmichael test. So again, you check bases from 2 to n-1, and what you do is you check to see if a to the n is congruent to a mod n. See if that's true. You do it for all of these numbers. And again, it's really important that we understand the conclusion. If any of them fail, so if this turns out to be false for any one of these, just one is enough, then you know you have a composite number. If it's true for all of them, then unfortunately we cannot say it's 100% prime, because it could be prime, but it could also be a Carmichael number. So we'll call this the Carmichael test. And it's pretty good. It'll catch most composites, right? But a few composites get through. So it's not a foolproof test. Just to do one more, a slightly bigger number is 2,701 prime. Now this is one that maybe we can't see immediately. Of course, we could easily do trial division, maybe with a computer. That would not be a problem. But let's go through it. So first we try base 2. Is 2 to the 2701 congruent to 2 mod 2701? So let's compute 2 to the 2701 mod 2701, and Wolfram Alpha tells us it is 2. All right, so that one passed. Let's try 3. 3 to the 2701 mod 2701 is 3. Looking good so far. 4. 4. 5. 1,966. So no. All right, so it passed the first 3. So 2701 is a pseudo-prime for base 2, a pseudo-prime for base 3, a pseudo-prime for base 4, but it's not a pseudo-prime for base 5. We caught it, and so we actually know now that 2701 is composite. It has factors. And of course, I'll use Wolfram Alpha to determine what those factors are. Factor 2701, 37 times 73. Okay, so not obvious at all. But it is indeed a composite, and a computer would have caught that through trial division. But we actually were able to do this, well, I don't want to say ourselves by hand, because we certainly used Wolfram Alpha to do the computation. Okay, so that's the idea behind what we have so far. We don't have a 100% foolproof test, but we've made strides in determining whether a number is prime by using this Carmichael test.